Yeah. So first, let's look at the execution mod. Right. So in general, a software is describable as a state action machine. Right. Often we say a sequence is a behavior of states, and then behavior is a sequence of states. So, but here, say state action machine. So this is the initial state, next one, and the next one, and so forth. And with the state action machine, we also say this is an action, this is an action, right? So multiple actions. So now, Resonate is actually like very structured. Right, our async awaitance, like very structured. So, what's a state? We can argue the state is all of the async executions, so all of the coroutines, and then the runnable coroutines, the coroutines that are waiting on stuff, and so on and so forth. Now the question is, what's an action? An action is a span, right, of some coroutine. So we take some coroutine and we run it from its current suspension point to the next suspension point. That's our atomic action in Resonate, right? We can take this one step. That is this particular action. Therefore, that particular action transitions the state, the Resonate state, from that state to the next state, to the next state, to the next state. So now it's actually really cool when we throw in assert.Always, because we get the intermediary states, right? So we can say assert.Always must be true on the initial state already, right? From the very get-go, that must be true. And then one of the coroutines takes a step, right? That means from suspension point to suspension point, from yield point to yield point. One of the coroutines takes a step, and that is, in our world, atomic. That thing just happens, right? After that, we can look again, right? So then we see that state again, and then assert.Always must be true again. And assert.Always must be true again. And eventually, if our behavior is not infinite, right, which in most of our cases it's not, because it's not an infinite loop, it typically comes to an end. Technically, it doesn't have to, but typically it does, right? So it comes to an end. Assert.Always is true. But not only that, but also assert eventually. Now, typical unit testing frameworks, right? They only do assert eventually. Like you start something, you call that method, it runs through the entire method, and afterwards you call an assert statement. They can only check that. We can actually really do something substantially different, where we check generically, right? You don't have to alter your code. Generically, each and every intermediary step, make sure that assert.Always is always true.